Good morning, everyone. Welcome to Concept Class. Today, we will learn about one of the simplest yet most important elements, hydrogen. We'll explore its position in the periodic table, methods of preparation, chemical behavior, and its role in oxidation and reduction reactions. Let's begin. Hydrogen is the first element in the periodic table with atomic number 1. It resembles both alkali metals and halogens. Like alkali metals, it loses one electron to form H+, and like halogens, it gains one electron to form H-. Because of this dual behavior, hydrogen doesn't fit perfectly in any one group, so it's placed separately in the periodic table. Hydrogen has one valence electron, so its valency is 1. It burns in oxygen with a pale blue flame to form water. Depending on the other element, hydrogen can form either ionic or covalent compounds. Hydrogen can be obtained from water in different ways, depending on the temperature. Let's see how it reacts with metals under cold, hot, or steam conditions. When sodium or potassium reacts with cold water, hydrogen gas is liberated rapidly. The metal floats on the surface due to the heat produced. Calcium reacts less vigorously, but still liberates hydrogen. Students can safely observe these reactions during a classroom demonstration. Magnesium reacts with hot water to form magnesium hydroxide and hydrogen gas. The reaction is slower compared to sodium or potassium. When steam passes over hot metals like aluminium, zinc, or iron, hydrogen is evolved. Notice that in the case of iron, the reaction is reversible. That means iron oxide can also be reduced back to iron using hydrogen. Non-metals like carbon also react with steam, producing carbon monoxide and hydrogen. Together, they form what we call water gas, an important industrial fuel. Hydrogen can also be obtained when certain metals react with dilute acids. Zinc and iron are commonly used for this purpose. We avoid nitric acid because it acts as an oxidizing agent and prevents hydrogen formation. Some metals like aluminium, zinc, and lead react even with alkalis like sodium hydroxide to produce hydrogen. This unique property exists because these metals are amphoteric. They react with both acids and bases. In the laboratory, hydrogen is prepared by reacting zinc with dilute sulfuric acid. The setup uses a Wolff's bottle. The gas is passed through copper sulfate solution to remove impurities like hydrogen sulfide. It is then collected over water, since hydrogen is insoluble in water. In industry, hydrogen is produced by the Bosch process. First, water gas is formed by reacting carbon with steam. Then, carbon monoxide reacts with more steam to form additional hydrogen and carbon dioxide. Finally, carbon dioxide and carbon monoxide are removed, leaving pure hydrogen. Hydrogen acts as a strong reducing agent. When passed over heated copper 2 oxide, it removes oxygen, forming copper metal and water. This simple reaction beautifully demonstrates the concept of oxidation and reduction. To summarize, hydrogen's unique position and behavior make it extremely important. In both laboratory and industrial chemistry, from being the lightest element to acting as a reducing agent and a fuel, hydrogen truly lives up to its name, the water former. Hydrogen's versatility is remarkable. It's used for making ammonia, hydrogenating vegetable oils, and even as fuel for rockets and hydrogen-powered cars. Its future as a clean, renewable energy source makes it one of the most studied elements in modern chemistry.